Um, let's try to see how we can approach this problem in a more efficient way. So we talked about how before um, prefix sums was able to solve range sum queries. And in this problem, we also need to sort of evaluate basically the range sum. So maybe we can use some sort of prefix sum logic to help us out. So I'm going to calculate a prefix sum p, and then right, so the first one will be 3, and then the second one's going to be 1, right, because I'm just going to mod everything by 7, because we talked about how addition, you can just do mods, and it'll be fine. It'll be actually easier because we work with smaller numbers, right? So this will be 3, 1, 2, 2 plus 6, 8, right? 8 mod 7 is 1, right? 3, 3, 6. Okay. So this is our prefix sum array. And we also know from the previous videos that P of R, right, is going to be minus P of L minus 1 is going to be the sum from L to R, right? So for example, let's say that my R was here. If I want to get the sum from here to here, right, and then I would basically just do 3 minus 2, right, because this will be left. And then we know that this range sum has 1. Will be, this range sum will have a remainder of 1, which makes sense, right? 6 plus 2, mod 7 is 1. Okay. Cool. So maybe one way we can think about this is, let's just set a right pointer, and then let's look at all the values before it, and then see if any of these ranges will be divided by 7, right? So 3, 1 in this case won't work. So let's try 3 minus 2, right? 3 minus 2, we would be looking at this range, right? And then if we tried like 3 minus 1 over here, we'd be looking at this range, and then so forth, right? And then if we see one that's divisible by 7, we sort of keep track of that length and compare it to the maximum length. That will also give us the correct answer, but that will still be too slow. That will still be n squared, because for each of these numbers, we potentially have to loop through like all the numbers before it for the left range, right? So that's not good enough. But how can we do better? What we see is that for this right range, if it's a 3, like what do we actually care about, right? Like we're just subtracting numbers to the left of it and then seeing if they're equal to 0, right? And if they're equal to 0, that range is going to be divisible by 7, right? So what actually matters is if any of these numbers is equal to 3, right? So for example, this one's equal to 3, right? So if I wanted to get this sum range, I would just do the prefix of 3 minus the prefix before it, the left minus 1. So in this case, this would yield us a correct answer, right? So this left pointer would be over here. So that would be length 1. And we also care about this 3 over here, right? If we do this 3 over here, we actually get our answer of 5, which is the overall global maximum answer that we actually want, right? So it looks like for each of these right positions, all we have to do is look at like if there are any, for instances, in this case it's 3, for any of the left-hand side, if there's like the same value, right? But what we actually care about even more is not just if they're the same, not just that they're the same value, but the earliest one, right? So we actually care about this 3 and then the earliest 3, because that will give us the best possible length, right? So that actually basically yields us the solution. So what we have to do is we don't have to calculate a prefix sum, but we can use that prefix sum idea of saying, okay, let's calculate the sums, the prefix. Well, actually, we do have to calculate prefix sums, but we're not going to be using it exactly the same way as before, right? So what we're going to do is first calculate the prefix sums, and then for each of these values, we're going to store the earliest occurrence and the last occurrence, right? Because that's really what we care about. So the earliest occurrence of 3 is going to be at index 0, and then the last occurrence of 3 is going to be at index 0, 1, 2, 3, 4, 5, at index 5, right? And then if we subtract this 5 into 0, that will give us the maximum length. Okay. sometimes you have to work out the indexing. Just in this case, this indexing works out, right? So sometimes, I don't know, depending on the question, you might have to do one-offs, or depending on how they're indexing their queries. It just depends. But in this case, 5 and 0. If we just subtract the max index minus the min index, it'll work. Okay. So we need to do this for all values, right? So not necessarily if it's just 3s, right? If we had, for example, like 1s, 2s, like this 1 could have potentially been an answer, right? But this length is smaller. We would store the minimum 1 and then the maximum 1. And we can actually do this in a separate array because the only possible values when we mod 7 in this prefix are like numbers from 0 through 6, right? So we essentially store an array of size 7 and then keep track of the minimum and the maximum. Hopefully that makes sense, but let's try coding this out. So I'm going to comment out the code from last time, and then for here I'm just going to say what we want to do is basically let's create the min and maxes, right? So the min and max for those indexes. So let's say I'll say min equal to new int 7. It's going to be of length 7. And then let's also say max equal to new int 7, right? What we can do is we can say that, or I think it makes more sense if we do it after, but let's just start populating it, right? So go through the entire array and then keep track of some sort of sum, and then add the number in the array in the sum. We can also mod 7, right, again. And then basically, like, if this is a 3 over here, we want the minimum at that sum, right? So to be equal to the minimum that we find so far, right? In the ith position, right? So right now the minimum will be minimum of 3 will be 0, right? As index 0, and then let's set the max over here to do some sort of similar logic, right? So this max. Okay. One thing that might not work right now is you see, like, for Java array creation, this actually creates an array all full of zeros. So essentially this all starts out as zeros, right? So this is not really going to work because our minimum is already 0, and then the minimum value that we can have in our index array is 0. So we actually have to fill this minimum with some big numbers, right? So I'm just going to say the biggest number that we can use. I think it's like this, right? We can also fill the maximum just for consistency's sake, but it won't really matter, right? So we can also set something like fill the maximum with the minimum value, right? Okay. So this is just to make sure that our comparisons over here will be correct. Okay. So what do we do now? Yeah, so after we get the min and max, right, we just need to look through all 7 of these numbers to see what is the maximum range, right? The range is going to be just the maximum, right, of this occurrence minus the minimum of that occurrence. So we can basically just loop through 0 to 6, then say that the answer is the maximum of the answer and max at I minus min at I. Okay. We might get some overflows. So because let's say max was this really, really small minimum value, right? If we subtract a number that's positive, this actually might go, because this actually might go overflowing negatively, right? So let me actually just make this smaller. Let's just say that this is n plus 1, and then this will be, let's just say that this is -1, right? So we don't overflow. N plus 1 is fine because right? N plus 1 is bigger than any of these numbers, any of these possible indexes. Okay. Cool. And then after, we can just print our answer onto the console. Yeah, so let's see if this works. Okay, 5. Cool. And notice how I have an extra printout statement. This is what you need for Usico, because we're technically printing out to a file instead of just to the console. So system prints out to the console, and out.println prints out to the actual file. Okay. So let's try submitting it to the website to see if this works. Okay, so I have it open here. I can submit solution. Okay, it looks like it works. So maybe to see something that would time out, let's use the original solution. Let me just comment back this code and make sure that still works. Okay, 5. And notice how if we do these printouts, it doesn't matter in this case because like we have an extra printout over here, right? It doesn't matter, it just looks at what's printed out to the file. But if a question is asking you to not print out to a file and just printing out to the console, it might matter, but in this case it doesn't. Just something to note. But let's try the inefficient solution and then see what the timeout looks like. Okay, so what this means is like for at least for Java, you get 4 seconds, right. So you can see that these test cases are timing out because our algorithm is too slow. This one is like at 2.1 seconds, and then these all exceed 4 seconds. So you won't get credit for those. Okay. But that's basically it.